So for this one, if you look at example 12.3, okay, example 12.3. Okay, example 12.3. Let me read something. Okay, this one. So this is pulley problem. Okay, pulley problem is a very popular problem. Okay, because you're going to use this again and again. We have here the two blocks shown. Start from west. Okay, you have block A and block B, and each of the block they have their own the mass, each 100 kilo and 300 kilo. Okay, 300 kilograms. Okay, so in this problem, what you need to find is, if you look at the figure, you can see that the horizontal plane and the pulley. Okay, the pulley. So these two, they are frictionless. Okay, and what you need to do is to find acceleration for each block. Okay, acceleration of each block, and then you need to find the tension in the cord. Okay, so what is our strategy to solve this type of problem? Okay, knowing that the concept that we have learned before in kinematics, okay, of particles, and also the topic that we have learned here. Okay, maybe any one of you can respond. You can type in our chatting room here. Okay, you say Zol said using Newton's second law, and then a free body diagram. Okay, all right. Any other input? My suggestion to you, for dynamic, you cannot treat every topic individually, you know, in partition. It cannot be like that, because we need to use different, to combine different concepts that you have learned earlier. This is like a building block. Okay, like a building block. Okay, so the first thing, if you look at the figure there in the solution section, you see here, first thing you have to okay, see here, this one, we need to write the kinetic relationship. Okay, the kinematic relationship for dependent motion. You still remember what we have write the relationship, which is, the first thing you need to know is what will be the total length. Okay, the total length, SA, okay, and SB, right? If you look at here, you need to know what would be the length here, right? And also what will be the length from here to here. Okay, so SA and SB, and then we have the main understanding also is the total length for the rope or for the string is constant. So that relationship is very important, okay, because you're going to use it, okay, you're going to use it again and again. After that, we need to find to write the equation of motion for the block and the pulley, okay. Write the equation of motion for the block and pulley, and then you combine the kinematic relationships with the equation in order to solve the question that been asked, okay, the question that been asked in the problem, which is this one, right? You have to find, number one is acceleration and number two is the tension, right? These two, okay? These are the questions, all right? Okay, now proceed to the next slide, okay? So the main thing to understand the free body diagram. Okay, now we look closely over there. You can see up there is how they put the datum here, right? So they have a datum here. To the right is positive and going down also is positive. Okay, this is positive, this is positive, right? Start with the datum. Okay, and then what we are having here is the free body diagram, okay, of these two systems, okay, the relationship for this dependent motion, okay. So you're going to have, look at here, we have, of course, we have a normal stress, normal force, okay, normal force. And then, do you have any friction here? Do we have any friction here? Why we don't have a friction here? Why we don't have a friction here? I have two screens, so I look at this this monitor. So I didn't look at the camera. Okay. 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 Correct. Because it's given in the problems, right? It said, or it state that it is frictionless, right? Frictionless. So that's why we don't have. So what we have here is only the tension of the pulley, right? Tension of the pulley. So we draw the free body diagram and kinetic diagram of this one, okay? So I try to enlarge the screen. Okay. So we have here the body weight and the tension and normal force of this one. And then we have the kinetic diagram of it, which is MA, okay, MA times acceleration of A, okay. All right. So this is straightforward, right? So this is what I have mentioned just now. This is the kinematic relationships, okay, for the dependent motion and acceleration of the block, okay. So this one has been simplified where you get here YB equal to half XA and acceleration of B equal to half acceleration of A, okay. Okay, this one is for block A. For block B, we're going to use the same thing, okay. The same thing for block B. So you have there the tension of 2, okay. Tension of 2, which is this one, okay, this one. And then the body weight of block B, okay, equal to 300 kilogram. Okay, so this is going down. Okay, block A. Okay, we have here block A. So we have here block A. Now we move to block B. Okay, this is block B. And then another thing that you need to look at also is this one. Okay, which is related to the pulley. Okay, the pulley that we are having here, right? So we have here the pulley. We have two string here. Okay, so you have T1 and another T1 going upward, and then going down is T2. Both are equal to 0. These are the three equations that we can write. Okay, related to this problem. Okay, this is number 1. Okay, fx equal to m times a. All right, and then you look at here, you have okay, T1, okay, 100 kilogram times AA. Okay, and then we have the second part of it, which is here, summation of force in y direction. Okay, so this one going to this way is positive, right? And this one going downward, right? Or is positive, right? And the third one, which is here, the relationship of this pulley. So you have we have T2 minus 2T1 equal to 0. Okay, these are the relationships of this type of problem. Okay, and then you can solve this problem by having or by knowing these three relationships. Okay, these are the answer for this problem. Okay, okay, I pause here. I would like to know if you have any question. You can write in the comment section, in the chat section.